Thank you very much for accepting our invitation to conduct the second part.
Good morning, everyone. So this will be the continuation of our previous session. So previously we discussed general concepts on cloud computing. We discussed what is cloud computing and the traditional computing models and some of the characteristics of cloud computing as well. Like we discussed about service models, like what is platform as a service, infrastructure as a service, and software as a service. We discuss those things and what are the differences. And then we discuss about different operating models, like what is a private cloud, what is a public cloud, and what is a hybrid cloud. So those things we have discussed. And if you have missed anything, maybe you can check the video. I think in one, we have recorded the video and people can access the video. There's no restriction. So if you have any questions from the previous session, please bring them up. I will try to answer my best possible manner. And so today we will move to the second part of the solution, which is building data solutions in cloud. This is about me. I am currently working as a senior solution architect at LB Finance PLC. I am a former MVP and currently a Microsoft certified trainer, as well as Azure solution architect. So I have a blog and YouTube channel, and my LinkedIn is active. So if you have any questions, or if you need any support on maybe mentoring, or if you need any assistance on whatever the projects that you are working on, it doesn't need to be on cloud. So if you need some general query advice or in general technical advice, you can contact me over there. I will share my contact details as well. So we have completed the first two modules, which is introduction to cloud computing and cloud service models. Then we are yet to complete the following modules, which is data solutions, app service, cognitive services, and how we can bring all those things and how we can build cloud native applications. So that is the trend. So you should be able to utilize multiple cloud vendors, like maybe your solution would be able to run on maybe Azure, then on AWS, Google, or whatever the way, with minimal effort. So that would be the target. We will try to, we will see how, what is the possibility in reaching that. Else we can work on, we will try to cover as much as possible the cloud workloads. This would be the agenda for the day. So the whole, in the session, we will be talking about building data solutions. So we will talk about a data solution. What is a data solution? And we will be talking about unstructured data. So this is just a small classification. So there can be some other, there can be other variations as well. So those are the very common stuff. There are some data solutions which will not fall under these areas. So I will tell you guys those things separately as well. So we'll be talking about structured data, the semi-structured data, graph data, and if time permits, we will talk about how we can work on the analysis part of the, how we can do data analysis. So this is about how we can build a rich data solution. So it is not about storing data in a database. So we have to think about the big picture, right? So when, let's say we are building a travel reservation system. For an example, I think you guys have seen some of the travel reservation sites, and there can be so many data points, right? So some of the data where user will input their data. So they can pick the destination, they can put the location, the time period. So there's a form, web form, the user enters those information. Then some of the information will be captured by separate devices. For an example, let's take a hypothetical scenario. There are sensors, there are some devices which can automatically detect, let's say, whether a hotel or whether a location is out of reach, or maybe the rooms are fully occupied. It will be, you don't need to go and find out. So maybe using devices, maybe let's take a parking slot in the same travel reservation the suite. So I'm not talking only about a travel reservation side. This is a complete solution. So let's say you need to, when a foreigner comes to our country, what they will do is, let's say they will log into the solution site. They will first, they will organize their trip, right? First, let's say in the first 2 days, he will go to Goal. Then the next 3 days, he will go to Kandy, maybe Anuradhapura. Likewise, he will plan his schedule. Then he will pick whatever the hotels that he would like to book. That's one part. Then he need to find out, maybe he need to rent a car. Then maybe in Kandy, he need to rent a bicycle, maybe motorbike. Then let's say he want to go to an occasion in, let's say maybe let's pick a big hotel, maybe Shangri-La in Colombo. He needs to ensure he needs to book a slot to park his vehicle for 2 days. So this is a complete picture. I hope you got my point, right? So it's a complete a solution. So let's say we need to build that. First, we need to find out what are the data points. Maybe there are several instances, there are several places where user needs to input his data, like the travel reservation site, the hotel booking part. He needs to input his information. Then maybe we need to get some information inputs from some sensors. Maybe let's pick the same example. In Shangri-La, there, let's say in car park, there are some sensors stored in, so you don't need to manually intervene. From those sensors, he can identify, the system can identify, okay, in third basement, in left wing, there are 2 slots available. Okay, so I can find it from the sensor. Then the system can get that information, and I can directly allocate that slot to this person, right? Or the next part is the system integration. So there would not be a person as such. There's no manual intervention. Maybe this is airline ticket booking. So there are so many ticket booking agents. So our system should interact with that air ticket booking site, the vendor, and it will input that, it will get those information, and maybe it will feed to our system, right? So you got my point. I hope you got my point. So there would be several multiple interactions to our system. Then those information will be inputted. Those information will be fed to my transactional data, which is my online transactional processing system. So that is also not single place. So whenever we build or whenever we think about a data solution, we will not think about one data source or one data storage. So it can be, as an example, maybe customer reservation data. We will put it in a database, maybe a relational database. I hope you guys know about relational database. Maybe think about a normal SQL server or MySQL, where there is a fixed schema. So that is relational. There are entities, there are tables, so there are interactions with those tables. So we have a relational database where we keep our reservation information. And maybe there's a place to store files. Maybe I need to feed logs into a separate location, right? And maybe there's a file share. Maybe there is another storage, another type of storage to store whatever the receipts. For an example, let's take the same scenario where a user reserves his flight booking and maybe vehicle booking as well as hotel bookings. Whatever the receipts, whatever the documents that are generated, we can put it in a file share. So those are only few examples. There can be multiple others as well, right? Maybe log whatever the logging transactions we can put somewhere, or we can put a queue because we have multiple integrations. Likewise, there are so many data storages. So those are data sources. I mean, those are inputs. Those are the data sources in my transactional data. It is not a single place. we can have multiple data sources here. And maybe later, maybe at a day in process, as a day in process, or maybe a scheduled process, what I can do is I can transmit that information into another data source, which we call as our data warehouse. So we can use this to analyze our content. So I think you have heard the term, data is the new oil, right? So data is the most valuable asset that we have in our organization. Currently the place that I am working on, it is not gold, or it is not the FD certificates that we value the most. It is the data that we value the most, because we have around, like, I don't know, maybe 30-50 years of worth of data. That is our biggest the strongest asset. In the same way, so whatever the data that is stored in transactional data, maybe person information, his travel history, whatever the things that we have it in here, we have to extract those information and store it in a place, we call it as data warehouse, which can be used to analyze that data. So in relational database, it is very hard because it is not designed to analyze. It's there to do the transactions. So we have normalized. I hope you guys had learned about normalization and those concepts. So it is normalized and optimized for transactions, not for analysis. But in analytical data, this OLAP model, the online analytical processing model, the data models are different. We have Snowflake, Star, those kind of different methods there, tabular, multidimensional, likewise. So it is optimized for analysis. This is ETL and ELT kind of data extraction model. ETL is extract, transform, and load. So we extract the data, and what we will do is we will remove whatever the unnecessary data, maybe the noise. We will transform, we will map to whatever the relevant formats, and then we will load to our data warehouse. That is one way. And the next one, which is maybe kind of popular at the moment with cloud, which is that is ELT, that is extract, load, and transform. Because in cloud, storage is very cheap. So previously, actually, one motivation for extract, transform, and load is from the transform, we delete most of the data which we treat as noise, because previously the storage was very expensive, right? But now it is not that expensive. So what we will do is we load everything to the cloud, then we will do the transformation. So we think at the moment, currently we think something as noise, but maybe in future we might value it. Based on that insight, we keep that information as well. Then we load whatever the analytical data, the information to our analytical processing component, and then we will develop the visualization. When visualization, what I mean, those can be reports, dashboards, so we can do the predictions. I think you guys have not noted about AI, machine learning, those concepts as well. So we can use those concepts, and we can develop rich visualization. We can predict. For an example, we can, with the usage of we will take the same example. Maybe by using analytical data, we can predict how many Indian tourists will come on maybe April. So we can with some sort of confidence, let's say with 80% confidence, I can say there would be 100,000 Indian foreigners would come to Sri Lanka, who will be from that segment. 70% of the fellows will be stayed in normal backpackers hotels, and the rest will be stationed in maybe star kind of hotels. So that kind of insight we can determine with this AI and ML with the help of our OLAP component. Then we can prepare for that, right? So that's the model. That is the data solution model that we need to focus about, right? I hope this is clear. So I think maybe forget whatever the cloud components that we will be talking about, but think about this. So this will be the key for the data solution. So you should know about those concepts. So what we will, in the rest of the session, what we'll be learning is what are the cloud components, what are the components in cloud that we can utilize in order to achieve each of them. In on-premises model, on-premises environments, I think you guys know that we can maybe to store transactional data, maybe we can use MySQL here, maybe file share, maybe another file share to keep some other component. Maybe we can create NFS drive, something like that. We can create the data source. Maybe some of the stuff we can still keep it in a normal text file or a CSV file. Likewise, we can have it in on-premises environment, and then in analytics data we can have let's say Microsoft SQL Server analysis services, which is the on-premises equivalent of OLAP, or maybe there are some other things as well. I think you guys have heard about something. There's something called Hadoop. That is also one thing. So those things we can put it in on-premises environment, and we can get the insight. So in the rest of the session, we'll be talking about how we can map those things into the cloud, right? Hope it is clear. Right. As I said, we will classify our whatever the data, whatever the data storage, data sources into several areas. The first one is unstructured data. So unstructured data is where data that doesn't have a predefined model, predefined schema. I think you guys know about the schema. Schema means maybe let's take a table. The table has a proper structure, right? It has, let's say, 5 columns: employee ID, employee name, address, surname, maybe date of birth. Likewise, there's a predefined a set of information that we are looking after, right? Likewise, that is only for one table that I had mentioned, but maybe in relational databases, there can be multiple structures, right? That is person, that is the employee. Maybe we can have a course table. That course table can have a structure as well. So that we can collectively can call as a model or a schema. But in unstructured data, there's no such a model or a schema. So one data item can have one way that can behave in a one model, and the next file that we have, next data element that we have, may treat in a totally different way. For an example, let's take video as an example. First, we can have a video file which is maybe 10 minutes long. Maybe we can store another video file which is 1 hour long, and all the parameters are totally different. Maybe there are some like text files, video, maybe audio files. Likewise, those are blob files. I think you know about what is blob. It's binary large object. So that is one classic example for unstructured data. The next thing is the structured data, which I have already mentioned. That data elements has a predefined model, which is a schema. So I have, this is kind of a table where I have columns specified, and rows will have representative, I mean, whatever the data elements matching to that column, right? A relational database is a classic example here. The next one is semi-structured data, where the data elements can have some sort of predefined model. I mean, it doesn't have the schema, but it has some structure. Let's take a JSON array, JSON file, or XML. Those files have a predefined structure, but the model, there's no fixed schema. We will while we progress, I mean, when we progress with the presentation, I will explain. Do you guys have any question so far? I hope no. Right. So we will move to the next item, which is Azure storage account. So this is the prerequisite for our unstructured data mainly. So the storage account will contain all Azure data objects. So when we, as the first step, when we create a storage account to create unstructured data, the first exercise would be to create a storage account when we talk about in Azure. So first of all, let me show what is a storage account. Right. Let me create one from the scratch. In Azure, you just need to click on just type a storage account here, and you can create. You have to select here. You need to type a storage account name and pick the performance tier and redundancy. So this is just a container. This is just think it as a folder, as a container. We first need to create this in order to have our blobs or files on it. And this is one setting, which is the redundancy. So we are given several options like locally redundant, geo redundant, zone redundant, geo zone redundant, likewise. So that's what I have mentioned here. The redundancy level, as it said, we have local, geo, likewise. So what it happens is, whenever we create a storage account and have items in it, it will have 3 copies, right? So otherwise we have to manually, let's say if we had it in local environment, on-premises environment, we have to have the backup, no? We have to have backup, or we have to create our own copies there. But in here, what it does is it will copy. Azure will automatically copy its content in different regions. So that's what redundancy level means. There are several ways also: local redundancy, zone, and geo. Those are the main items. So let me share a little. Give me a second. So guys, you can hear me, right? Hello.
Yes.
Right. Okay. So in here, let's say we have, if you take local redundancy, let's say we have so let's take we have data centers here. There are several ways we can place. This is one region. Let's take one region. That region can have different zones, maybe data centers in one region, zone 2, zone 3. So for an example, let's say this is Asia. In Asia, maybe let's say this is Singapore. In Singapore, we can have 3 data centers. If we had selected zone redundancy, it will have copies in zone available. Right? Let's say in the data center, if one zone goes down, if let's say this goes down, still we have 2 copies. This is one model. And another one is regional one. Let's say this is, for an example, let's take one, maybe China. If we go for geo, then you have copies here as well. So let's say if entire region goes out, still you have some copies available in another region, so you can get it from there. Some of the stuff, I mean, if you have regional, this is by default this is read only, but there are some other ways where you can have write copies as well, so you can make it available, make it write ready as well. And there's another concept called life cycle management, where we can have multiple tiers, as I said. So as I previously said, maybe in my first session, in cloud, we pay for the stuff that we have used. Let's say we need to upload a lot of content, but we don't need to read them. We upload them because of compliance reasons. Let's say our receipts, whatever the documents that we generate, we need to store it somewhere for 2 years. Let's take, there's some regulatory requirement. Although we upload it in cloud, we can put them in archive here. So we need to pay very less. So in performance tiers, we have three items. First one is hot. Hot is bit expensive. So the cost, if you take cost wise, this is bit expensive. Then we have cold. We can put maybe whatever the files which are rarely accessible, but we need them whenever there's a request. We need to get that file. Then we have to put it in cold. The next one is archive. In archive, we cannot directly access those files. We need to request and get it copied to some other place, and then we can access. There's something called hydration. So it might take hours, or maybe it can take up to maybe days in order to get into other tiers, right? So we can categorize. So in order to reduce our cost. So if we need something accessible very quickly, then we put it in hot tier. So there's something called life cycle management. We can create a script and we can schedule them. For an example, let's say at the moment, whatever the most recent artifacts, most recent customer information, whatever the flight booking tickets that he had in our previous example, we will first put it in hot tier. Maybe after 15 days, we will automatically transfer it to the cold tier, because it is rare that a person will request his flight tickets after 15 days. That is as an assumption. But he can ask, we need to give it as soon as he requests. But that resides in the cold storage. But after some time, let's say after 6 months, we will move it to the archive storage. That's because that's due to some regulatory requirement, because if there are any legal issues, a customer can still request those information. But after 5 years, we can delete it from our storage. So in that way, we have to plan the storage with the tiers and using life cycle management. Right? I hope you got the point. So it's not straightforward as we work on normal on-premises environment. So what we will do is, whatever the garbage, whatever the information that we have, we will just dump it into our databases. We rarely think about the data growth or how we can classify those things. But in cloud, because it is managed and we have to pay for each and every kilobyte, every byte that we have, there's a cost. So we need to plan. So if you guys are creating a solution in cloud, maybe some testing or maybe
at your workplace when you go to a job. So this part is very crucial. So you need to plan about the life cycle management, how long this information will reside, what is the data source that you need to work on, whether it is structured, unstructured, semi-structured. Those are the main classifications. So you need to pick, you need to break your system and find out what piece should go to which area and what would be the life cycle part of that, right? That's one part, that one important part. The next thing is about the security. So as you can correctly assume, so anyway, this is in cloud, this is someone else's servers, right? So what we are trusting our information with someone else's servers. So whenever we create blobs, whenever we create containers, whenever we create storage accounts, we need to focus on the security, authentication, and authorization parts. There are so many ways that we can implement authorization and authentication. I hope we discussed about something called Azure Active Directory. There's something in Azure. There are some other equivalent product in other cloud vendors as well, but we will focus on Azure here. In Azure Cloud, there's something called Azure Active Directory, where we can create users and groups. We can bring that here. We can create AD, Azure Active Directory based authentication and authorization. That's one part. And there's something called shared access signature. You don't need to worry too much. We will develop something just to give you the theory part of it. There's something called shared access signature, where we can create a key which will be available only to a segment of users which you have approved, and it is available. That key will be valid to a time period. So there are so many parameters I will show you. By creating that, you can create a key. If some person has that key, then he can access the information. So in the key, it's a basics to encoded string. So in that string, you can specify whatever the relevant information, like what are the accessible areas, what sort of right do you have, whether it is create, manage, delete, or view. Likewise, you can put whatever the controls in that signature, and that signature, with that signature, you can access the storage account and whatever the contents. And in very simple terms, we can create anonymous as well. So we can block the authentication authorization. We can ignore that part. So for testing purposes, we can do that, but it is not recommended in any production or other implementations, right? So let me again go to the storage account, right? So I hope this part is clear. We discussed about geo redundant. Geo means it's available in multiple regions. Locally redundant means it's only in one place. Zone redundant means in a region there are multiple zones. Likewise, it's available. So we can create the storage account because it will take some time. I have already created a storage account. So this is the landing page of a storage account. Using a storage account, we can create container. Container is to store our blobs, binary large objects that may be videos, files, whatever the PDFs that you generate from your application. You can easily upload it in here and read it. And the next one is file share, queue, table. So those are the main elements that we have, right? Let's progress with the presentation. Right. So this is about the blob storage. It mentions that scalable and secure object storage in cloud. There are few variations in blob as well. We can create blob, page blob, and append blob. Blob is where you can create videos, other types of unstructured data like maybe video and any audio files. Likewise, those things are blob. Page blob is maybe we can think about the virtual hard disk. Actually, inside Azure, you can create virtual machines. That virtual machines have a hard disk, right? Let's think about your own laptop. It has a hard disk. In the similar way, a virtual machine, which is infrastructure as a service workload, that virtual machine has a virtual hard drive. So that hard drive is also stored in the blob storage, and it uses page blob, right? Then the next type is append blob. Append blob is where it can easily append to the last place. Like think about a log file. So log file is growing every day, right? So every time, if there's a new log entry, there's a new append entry. So for that, the best suitable item is append blob. So those are optimized for their own workload, right? Let's go to the blob storage that we have created. We have created a storage account. Under that storage account, let's go to the containers. We can easily create a container. For the simplicity, this is what I mentioned. So this can have private blob level access, and I will just put anonymous read access to make our lives easier. So can create the container vehicles. Then I can easily upload from the portal, but I'm showing you the simplest way where I can log into the portal, the Azure portal, and upload this. But anyway, think in logical terms. If we have an application, we cannot ask our end users to upload, go to the portal and upload, right? So there are so many other options where we can utilize the blob container, and from our applications, we can upload those things. So let me. Right. So I will upload this picture. So it will be uploaded here, and I am given a URL. So this is my cloud storage for my vehicles. As I said, I can utilize many ways from to access this container, blob container, from my application. Let's say I have an application written in .NET. What are the ways that I can use? I can use the .NET SDK, the storage account, the blob storage SDK. I can utilize that, or I can use the REST API. Let's say I'm developing a very small Angular application, front-end application. Then I can easily use the REST API with whatever the credentials that I have. I can access this information. Let's try that out. Okay, let me find a URL. So before showing you that, let me give you the REST API reference. Okay. Okay, so this is for the storage REST API reference. This is applicable for all the items like blob containers, files, file shares, queue, tables. Likewise, this is applicable for all the storage services given there. So if I will share this URL, so it has an API reference. Now let me just show you the this REST URL. This is my storage account, and my container. Container was vehicles, right? Remember, I create a container called vehicles, maybe. Right. So you can see, since I have made it anonymous, it doesn't require me any token. It just give me whatever the results. So you can do the same way. You can just create a container, upload certain information, and using maybe HTML, maybe Java, using JavaScript, or maybe if you are comfortable with any framework, React or maybe Angular, just create a small application. Then you can show, maybe create a grid kind of thing where you can show whatever the vehicles or whatever the animals that you have it in container. You can use the URL, you can manipulate, right? So we can do that. So that is how you can access using the REST API. It's one thing. And there's another solution where you can deal with data in Azure. There's a tool called Azure Storage Explorer. So let's say, let's think that you don't have a cloud a tenant. Let's say you don't have a subscription yet, but still you can build a solution. So what you can do is just download the Microsoft Azure Storage Explorer, which is a free tool, and you can create a storage account locally and Blob container locally, and you can do the development easily without any tenant, right? So since I have storage, I have a tenant, I have a subscription, I can list them there, but without the subscription also, you can download it here. You can go to the storage accounts. You can create a Blob container. You can create a new Blob container. You can do whatever the things that you would like to do. In here, this is my storage account. Under that storage account, let's go to my Blob containers. I have the vehicles container. Vehicle, either I can upload it from here, I can do whatever the manipulation that I would like to do, I can work there. But most important part is that the local and attached stuff. If you are developing some component, developing a tool, so this would be the place that you would like to work on, right? Right. Let's move to the next part. Right. So this is about a file share. That is the next item. It says managed file shares in the cloud. It supports all the common protocols, NFS, SMB is normal file share protocol that we have. If we have implemented a file share, I hope you guys have some sort of a file share in your university to upload some content, or maybe as your knowledge base, you may have a file share. It would be the same way, but the difference is your file share is not located in your university. This file share is located in the cloud. And the nice thing is that you might feel that okay, it will be very slower. So let's say I have a file share in cloud, then it will take long time to reach that file. So what you can do is you can synchronize with your on-premises file shares. There's something called Azure File Sync. Let's say you upload a file to your on-premises file share, then it will be synchronized and it will be uploaded to your the cloud file share. I hope you guys know about have worked with maybe OneDrive Pro, those things. Also, if you have synchronized one folder, whenever you add a file to that folder, it will be replicated to your cloud, your OneDrive. It would be the same way. Whatever the items that you add in your cloud, it will be visible in your local file share, or in the other way around also. If you add the file in your local, it will be available in the file share, and the other way, I mean, both ways it can work in. Right. So why do you need to have a file share in cloud? So if you have a file share in local storage also, then it is sufficient. The thing is, the storage is cheap in the cloud. As I said previously also, storage is very cheap in cloud. What you can do is, you can create archive policy. Whatever the older files, whatever the maybe assignments that you guys had done 6 months back, you don't need it in your local file share. You can move those stuff into a file share. That is one way. Or you can segregate. You can divide based on the need. You can upload some of the files in file share in Azure and utilize some of the other cloud workloads. Maybe that those files will be accessible from another university. Maybe you guys are working on a project with let's say University of Colombo. So University of Colombo guys also need to access the same file as well as you also need to access. So it's not practical. Let's say it is not practical to allow access to your own on-premises file shares due to some security, compliance, or some other reasons. Then easily what you can do is easily create a file share in cloud, create a synchronization from both the parties, both the locations, and you can collaboratively build a very nice solution, right? So those are some use cases. So let me go to the Azure again. Give me a second. Right. So this is file share. You can easily create a file share and just you need to give the name. And remember, I mentioned about the tiering, whether it is hot, cold, archive. Likewise, this is applicable to the file share as well. You can do that way. So I have created a file share already. We can create folders, we can upload files, and there's a nice feature called Connect. So what you can do is either Windows, Linux, or Mac OS, you can map the cloud file share as a mapped folder in your. If you go to my computer, if you are in Windows, if you go to my computer, you can locate the connected network drive here. So you can just as you work with a normal Windows folder, you can add content, you can access content that is secure place there, right? Hope that is clear. Right. Let's go to the next item, which is queue storage, right? Do you guys know about queue? What does a queue do? Any idea? Before I go to show a queue. Right. So queue is where we try to implement in our solution. Let's think about our solution, about the travel, the large solution. So we will work with multiple components, right? So we need to access travel application, I mean airline ticket reservation system, which is developed by someone else, some other party. Maybe we need to communicate with hotel system. As remember, in my system, it directly talk to the car park solution developed by Shangila, right? So it need to access the telemetry data. It need to access sensor data. So it need to access that. And maybe hotel reservation, if they have their own systems, I need to integrate. So there are so many integration points, right? So what if, let's think about the normal way, I mean the contemporary way, the traditional way. So what we will do is, if they have APIs, what we'll directly do is, we will call from our application. Let's hope our application is a mobile one, mobile React or Ionic application. From that application, we will just do a HTTP call to the hotel reservation system, or to the airline reservation system, or to the car park management system using a simple HTTP call, and I will get the result and I will work on it. What if that system goes down, right? What do you think? Let's think about the airline reservation system. For some reason, it goes down. Then what happened to my entire solution? It will break, right? So there is a direct dependency, tight coupling with the external system, which is not good. Anyway, since we are using a web API, we are using API, some of the coupling part is gone, but still there's a tight interaction, tight coupling with external bodies, right? If something goes wrong in that module, that system, our entire customer experience will be damaged, right? And let's think about the car parking system, which is introduced by the Shangri-La or the hotel. Let's assume one developer from that side, he introduced one additional parameter in their API. Now everything breaks. We have the older version, and no longer our system is working. Our system is breaking now. So we need to eliminate that kind of practices in our general application development side, as well as if we go for a cloud, because we are paying for whatever the things that we are using, either it is working or not, we have to pay, and we need to optimize whatever the things that we are using. So based on those two concepts, we need to eliminate the tightly coupledness that we have to eliminate, and we need to ensure that our application is scalable. Let's take about the same scenario. What if our customer demand is too high, and we can optimize our solution. We can break our solution and put it into multiple applications or multiple API. We can bring our side of the solution into a state where it is scalable. But what about the other parties? Let's say that car parking solution is done with very small resources, and it is not able to scale. Maybe it is an older system. So what would happen? So it would be the bottleneck of my solution, right? The entire system will be slower because of some external dependency. So that is also one thing we need to avoid. So the queue storage is a nice solution. This is not the only solution for that kind of scenario, but queue is very nice solution for that. It helps us to decouple the application components with asynchronous message queuing. Let's take the same scenario. We have an external system, which is our airline reservation, and from our system is the front end to the customer. He will enter whatever the information. With that information, previously what I did was I have a service call directly to the airline reservation system. Then it will do the reservation and send me a status code. If it is successful, it will send me 200 as the code. Then I determine it is success. Or if it sends me 400 or 500, which is not 200, then I will fail the entire transaction. That was my previous approach, which is not good. So in this scenario, what I will do is, in the middle of the integration, I will implement a queue. So my system, I will, whenever a customer inputs a flight reservation request, I put that information, the body of that call, I'll put it into a queue as a message. Then once it is populated, the other party, which is our flight reservation system, it can interact, it can scan the queue, and it will get the message and do the stuff, and what the response also it will put into a queue. Then it will be listened by my application, right? So middle, there is a kind of a separation. There's the component we have introduced to reduce the coupling. So whatever the changes that whatever the changes done by the flight reservation system is not impacting my entire system, right? So let's say for 30 minutes that flight reservation system is down, still people can request flight reservation information because it will be populated in the queue. And as soon as the flight reservation system comes back online, it can scan the queue and it can cater those information. And we can implement a queue in a scalable manner as well. Let's say if I have multiple queue messages, then I can quickly bring up another queue. Likewise, I can implement high availability as well. Let me show you a queue storage. Right. In here, if I go to a queue, I can just type here and click on type a name of a queue and to create one. And I have already created the queue. I can just click on the message, put my message, let's say flight reservation body, the JSON itself. I can put it here, the body, the output from my API. We can put it here, which will be read by the flight reservation system. So I don't need to go to the container, the Azure portal. I can use the API. I mean Postman. I can just show you the Postman. I don't think it will work because those are some older information. So just to show you, so it will be, let's say, post message. I just need to put a message, and in the body, I will put my message here. Then if I put it, it will be entered to my queue, right? Because it will not work out because the key is, I think it is old. So you just need to pass those information, the authorization key, then it will be updated in my queue as a message. So that is about the queue storage. Right. So let's move to the structured data, where we work on the relational database. So structured data, as I said, it has a schema. That is platform as actually previous ones are also platform as service offerings. We don't worry about patching, or we don't create the instances. We just use the offering which is provided by Azure as a service. Right. Let me quickly show you Azure SQL as well. Right. Let me close this. If I put SQL, so you can see two items, SQL servers as well as SQL database. I hope you guys have worked with SQL server, or MySQL is also fine. First we install, right? First we install SQL server. Then in that SQL server DBMS, we create our databases, right? So this is also something similar, but since we are in cloud, we will not install SQL server. What we'll do is we will provision an instance of SQL server for ourselves. We can just go to SQL server and create one SQL server. I have already created the SQL server, and if I go to SQL, then I can create SQL database, which is using the SQL server instance. So if I click on SQL database, I need to put the resource group, and here server, I need to create the SQL server instance that I have created in my previous scenario, or else I can create another instance as well. So I have created a SQL server database. So that database is using the SQL server demo SQL. This is my server, right? So this is my, if I need to put the connection history, so this would be the server name. The database would be the person DB. So I have created the database, and you can easily manipulate data with query editor. This is I have used SQL authentication. You can use Active Directory, or there are some other options also. For the simplicity, I have created this one. So you can create tables, relational tables here. So you can write whatever the queries that you would like to use. And I need to mention about another tool. Have you guys heard about Azure Data Studio? So this is, I think you guys have heard about SQL Server Management Studio. It is kind of a bulky and it's heavy duty. It can do so many things. But if you are working on cloud workloads, if you are working on Azure database, this would be, I mean, more than enough. So I have connected to my same database. If I need to connect, I just need to put the server name. That is my overview. This is my server name. And since I have provision, I am using SQL login. I have to use that. Otherwise, Active Directory, I can use Active Directory, username, password. Once it is done, you need to provide the database name, which we have created already, right? So close this one. Right. So in SQL Server, whatever the things that we have normally in SQL Server, tables, views, the stored procedures, views, those things we have within Azure SQL as SQL database as well. But if you need to configure jobs, if you need to have, connectivity between two SQL Server databases, so this will not be the best suitable one. But if you are creating a simple application, this would be more than enough. So from the SQL Data Studio, you can create data, you can edit data. You go to edit data. It will take some time. You can run queries, normal TSQL. It works in cloud as well, right? Okay, until this loads up, we will go to the next one. So the connection string, okay, this is one sample. So connection string, so you can get it from here. You can generate from here. Authentication, authorization, you can generate nicely. Right, let's talk about semi-structured data. So the first one is table storage. The table storage uses the NoSQL key value pair. I hope you guys know about NoSQL. So there are, for that abbreviation, there are several interpretations. NoSQL, some guys argue that is not only SQL. Some guys say it is NoSQL, like this. But I think not only SQL is the correct one, because we can use we can use relational concepts, some of the relational database concepts in NoSQL as well. Let's go to the, I will show you the table storage as well, where we can store as key value pairs. I will go to the storage account. Table. Here I have created one table here. And I will navigate to the Azure Data Explorer, which would be the easiest solution here. Go to the storage account. I will go to table storage. Go to the table that I have created. I have one record already, and I can create another record. But record to record, we can have different schema. That's what I mentioned about semi-structured. Here you can see there's in the table, this row has these columns, but in the next record, we can add another column, right? You got my point. I hope you got my point. In previous record, only name, partition key was there. In this record, I can put address as well, right? It is key value pair kind of thing, right? Great. As I said, it is flexible schema. Let's talk about the Cosmos DB, which is a bit of an advanced topic. It is also using NoSQL, and the most important part is that it has several APIs for us to access data. It's not only one the hard-coded one static thing. When we create the database, we can specify what sort of API that we need, whether we need normal document API kind of thing, or maybe column storage wise, or the key value pair wise. We can specify when we create the database, and it has varying consistency models. Let me show. The first one is it has open source API support. That means we can create the Mongo database. Likewise, we can create a Cosmos database instance where it will behave as a Mongo database, right? It uses MongoDB API. I think you guys know about Mongo database. That is also a NoSQL implementation, a document database, which also has a key as well as a partition key. We can partition our content with the partition key, and the key is also there, and the rest, the value would be a document. It can be a JSON, it can be a unstructured file, it can be image, whatever the way. So it is organized with the key as well as the partition key. Then the next type is, if we want to have a column storage, then there's something called Cassandra. We can create our Cosmos DB instance as Cassandra, and table storage that we have just learned about. So if we use table model, then our Cosmos DB will work as a table storage. So we can specify key value, yeah, likewise. And there's some important unique characteristic which called as multi-region writes. So let's say we have a SQL server instance. Forget about the Cosmos. The SQL servers, we can have clusters, right? Maybe you guys have not worked with clusters, but what we can is do in real world, real environments. We don't trust one database instance. It can fail. Maybe we need to load balance. For that, we can have multiple SQL Server databases which use one listener. Then whenever I write to one node, whatever the data item that we store will be replicated to other nodes. So other nodes, whatever the other nodes that we have, work as read-only mode. So we cannot write to all the nodes. Let's say although we have five nodes in my cluster, I cannot write to all those 5 nodes. Always there is one write-only node, and others work as the read-only nodes. But in this scenario, it allows multi-region writes. For an example, let's say your application which is available in Asia, you can have one Cosmos instance where people from that region can access to that, and maybe people from Australia, they can have their own instance and they can write to that node. But how we can ensure that all the databases are end of the day consistent? So to do that, there are 3 models: strong consistency, session consistency, eventual consistency. Session consistency means whenever you have a session, whatever the items are consistent, whatever the data are consistent for your session. And eventual consistency means, so those data items are, whatever the items are written in Australia Cosmos database instance will be stored there, and whatever the data items which were written in the Asia, maybe in Singapore, are written there, finally they will talk to each other and make it consistent. But it will take some time. So that is the trade-off actually. So we can have it, but let's say some person first access some resource in maybe in Singapore, in Asia, and he quickly goes to the next region, maybe fly to the next region and see the information. It might not be updated because still the synchronization did not happen. So maybe we can, I think maybe you did not get every part. So we need to do something. We need to try out. Maybe in a next session, in a future session, we will try to create one sample with Cosmos, and we will try to implement our application. So it will be a great exercise.
Thank you very much for your time and the great session with your busy time schedule. Thank you very much, Mr. Vinshay.
Right. Thank you, guys.